we are going to take a look at this new machine. This is a Rotary T17 engine lathe. And it is powered by this three-phase rotary converter. It's a three-phase lathe. It's a 7.5 horsepower motor. So to power that, I had to come up with a converter here. This is a 10 horse three-phase motor, which is acting as an idler motor, a rotary phase converter. So the way these work is you hook them up to 220 on two legs. So you can see the two hots coming in. That's 220 on one leg, 220 on the other leg. The third leg is not connected to the wall. It actually generates that internally by spinning around. So there's a few other things here on the pallet. We got some large capacitors to help it start up quickly, some smaller capacitors to balance out the phases, and a couple of relays and things to control startup and shutdown. This is a low voltage control circuit, so we've got 24 volts that runs to this stop and go button, and that's being provided by a power brick on the side there. I got a few of these components from Henry Austin, mostly this guy, a very large contactor, so thank you, Henry. And we will fire it up here in a second. So this lathe is really big. It's really bigger than we need, but it was pretty cheap and it's very lightly used. It's in good shape. It's not rusty at all. So we've been playing with various functions on it. Last thing we set up was a boring bar. One other thing to show you is I have the voltage meters set up here so that we can check what the voltage of the three phases is. Each one of these is between two legs, so this is between the two utility legs, so this is a reference. This is provided by the utility between 1 and 2, and this is between 1 and 3, and this is between 2 and 3. So those are the two that I have to control for with the capacitors. And in an ideal world, they would all be identical because you want to provide equal voltage to all three. So we also have it running through a shutoff switch so that if we have to, we can shut this off quickly. That will just disconnect the three-phase converter from the lathe. We also have this whole thing on a 30 amp breaker, which is also goes back to the main fuse box over there. So everything's pretty safe. And oh yes, one of the safety feature that I came up with is if the power shuts off to this and this thing spins down, when the power comes back on, this will not spin back up until you turn it on. That's part of what these relays are doing. So let's fire it up. Okay, you can see it started real quick. Spinning just fine. I've got this protective cover over it so that nobody gets their finger stuck in there. You can see the light is on. We have power. Check the gauges here. And all three of these are one notch above 250. The power output is a little bit high here, but that's okay. The lathe doesn't mind. So we can turn on the coolant pump. Coolant there. This is a mixture of water and lubricant. And then turn on the lathe. Controlling that with just this little switch here. Works really well. I'll let you see what the gauges do when I turn it on and off. Let's see. Get this position just right. to go. You know, it's not 100% perfect, but it's good enough. Now we'll turn off the coolant pump. And yeah, this little guy over here really doesn't draw any power because he's not doing any work. All the power is going straight to the lathe. They tell me it's about 80-90% efficient, the power that's going through here. So this is a good old time motor. Duty Master AC motor. 1755 RPM. Continuous duty, 3-phase. I mean, clearly made in the late 60s or something like this. And shut it down, just push the stop button, and it stops. Thanks for watching.